वेट करें आने का या फिर स्टार्ट करें ठीक है. Okay. Classification of elements and periodicity properties. Okay. See, as we know, okay, as we know that there are more than 100 elements. Yeah. Okay. So scientists they need that there should be they require to feel the requirement of classification. Classification means what? Grouping of the elements. Okay, grouping the elements. Just as we see in our school, in everywhere. Okay, there are some classes. Just we can take an example of our school. What we see there are classes one, classes one, class one, class two. All the students of class one are alike. Okay, the same thing happened here. They do the same thing. They want to, because each and every element, to study the properties of each and every element is not an easy job. So to study all the elements, they start classifying them. Okay, on the basis of their properties. So for that, okay. So in that the first we'll discuss with the history of the periodic classification. Okay. So the first scientist, first chemist who gave this classification was the Dobenias. Okay. The law of triads by Dobenias. Okay. In 1864. In 1864. Hello. Hello. हाँ. नो मैम नहीं दिख रहा है यहाँ पे. नहीं. नो. ठीक है. तो फर्स्ट वन वाज बाय द डोबेनियर्स. ठीक है. डोबेनियर्स लॉ ऑफ ट्रायड्स. ठीक है. व्हाट हैपेंड हियर, द डोबेनियर्स arrange the elements. ठीक है. या if he grouped the elements of, he make a group of 3 elements. ठीक है. In that, the atomic weight of the second element equal to the arithmetic mean of the first and third elements. Okay. Means what? Okay. He grouped the elements of 3. Okay. Like lithium. And yeah, the first thing should know that Dobenias arranged the elements on the based on their atomic weight. Okay. On the basis of their atomic weight. Okay. He grouped elements like see, 3 examples we'll take. Lithium. Okay. Lithium, sodium, and potassium. Okay. And what is the atomic number here? Lithium atomic number is 9. Sodium atomic number is 23. And potassium atomic number is 39. See. So what he did here, okay, he make a group of 3 elements. Okay, like this. He make a group of 3 elements in which he told that this is the middle. Okay, atomic weight of the middle one is equal to the arithmetic mean of the first and third. Okay, you want let's calculate this. Let's calculate the arithmetic mean of the first. 9 plus 39 upon 2. What it will be? Correct? What it will be? 24. It almost the same. Okay, almost same. So he grouped like this. Okay. Same way he grouped beryllium, magnesium and calcium. Okay. The atomic number of beryllium is 9, magnesium is 24, and calcium is 20. What is the atomic number of calcium? It should be 40. Wrong given. Okay. If you will calculate, if you will do the calculation here, if you will take out the arithmetic mean of the first and the third element, what you will get? Second. It will is equal to the atomic weight of the second element. Okay. So this was the Daubernier's triad. Okay. This way he could arrange a few elements, few groups of 3. Right? But he could, but it was not at that time because it was his first attempt of grouping. But after some times, it was failed. There was failure of this element because he could not explain about all the elements. Okay? He could not explain all the elements like this. Okay? As we go on, as we go at the increasing atomic weight, okay, this law, this Tobenia's triad was not successful in explaining this. Understand? So, first of all, Dobeniar's curve, he grouped with the 3 elements. He make a triads of 3 elements. That's what's called Dobeniar's law of triads. Okay? After that, after Dobeniar's, after the failure of Dobeniar's triad, okay, the next one is, next come Newland's. Okay? Newland's. Okay? Newland's law of octave. According to the Newland's law, okay, if the elements are organized in atomic weight, here also, Dobenias also arranged in with atomic weight, and Newland's, he also arranged the elements on the increasing atomic weight. Okay? An atomic weight order. The 8th element, starting from a given one, is a kind of repeat of the first. Okay? Means what? 8th element. 8th element is the repeat of the first. Okay? It was analogous to music. Just like in music. What happens in music? It has 7 notes. Yes. Like sa, re, ga, ma, pa, dha, ni. And 8th one is the repetition of the first. Same way he did in the atomic with the element. Okay. 8th one is the repetition of the first. Okay. Let's see. Lithium, beryllium, he grouped like this: boron, carbon, nitrogen, oxygen, fluorine. Okay. First, second, third, fourth, fifth, sixth, seventh. Now the 8th element. That is what? No. That is what the sodium. Here in Newlands. Okay. That is what sodium. The 8th element is the has the same properties of that of the first element. Okay. That is starting with the lithium. The 8th element is sodium. And the properties of the lithium and sodium should be comparable according to this law. Okay. This is the 8th element. This is the first. If we will start with the lithium, 8th is the sodium. So their properties are comparable. Okay. And after that, if we will see sodium, then magnesium. Okay. So these two have this comparable properties. Okay. Understood? So this way he arranged the atomic arranged the elements on the basis of their atomic weight. Okay. But later on also he could not explain the what happened later on. He could, because he could not explain all the elements. Okay, and it was applicable to uh, up to a few elements only. Okay, with heavier elements, with heavier elements, he was not successful. Okay, so after that, what happened? After that, then Mendeleev's periodic table. Okay, then Mendeleev's periodic table. Then Mendeleev come and he gave a periodic table. Okay? Again, okay? Again, he arranged the elements on the basis of their atomic weight. Okay? What he said that the according to Mendeleev's law, okay, the physical and chemical properties of elements are periodic function of their atomic weight. Okay? Means what he said, physical, you don't want to write. Yeah, I okay, okay. You missed the note. No? Okay, stats you have done. Yeah. Okay, okay. Same way. Yes. Newland's law. Okay. Then Mendeleev's. Okay. Let me explain. What was the Mendeleev's period? His was physical and chemical properties of elements. Okay. Are periodic function of their atomic weight. Okay. It means what? What it means that the elements are arranged on their atomic weight. Okay. And he gave a term periodicity. Periodicity means what? Repetition. What is the meaning of periodicity? Repetition. Like the elements of group first. Suppose this is the elements of group first, lithium. Okay. After repeating, it becomes there is sodium. Okay. So this is the repetition of the properties. Okay. Okay. So the properties are being repeated. The physical and chemical properties of the elements are being repeated after a fixed interval. This is called the periodicity. That's why it is named periodic table. Okay, because they arrange the elements in the tabular form. Okay, where their properties are repeated after a fixed interval, and that is called the periodicity. Okay. You have done, but it's not mixed up. Right? Mixed up. In the problem. Just try to understand. Okay. Pendle's periodic law understood? Yes. At atomic weight. Okay. He told about the periodicity. Periodicity means what? Repetition of the properties after a fixed interval. Okay. But there were some defects. Because there were some drawbacks. limitations. Limitation was what? Elements with a varying atomic weight, such as lanthanides, are preserved in the same group. Isotopes do not belong in the periodic table. What isotopes? What are isotopes? Okay. See, he arranged the elements on the basis of their atomic weight. Correct. But there are isotopes. Isotopes means what? Okay, better write down. Isotope. Okay. Elements having same atomic number but different atomic weight. Okay. Atomic weight. So what happened here? That Mendeleev arranged the table on the basis of the atomic weight. Okay. But there are some isotopes. Isotopes means elements having same atomic number but different atomic weight. Okay. For example, hydrogen. Okay. Hydrogen atomic number is 1, atomic weight is 1, and the next isotope is atomic number 1, atomic weight 2, and the 1, 3. See, all are hydrogen, atomic number are same, but different atomic weight. Okay. So, but in what happened in Mendeleev's periodic table, okay, he arranged the elements on the basis of the atomic weight. But here, see, there are 3 isotopes of hydrogen. Means what? There are 3 hydrogen has 3 atomic weight. So where could he arrange the one hydrogen? If he will arrange here with atomic number 1, what about 1 and 2 and 3? Where they will go? Understand? So he could not explain the isotopes. Okay. Likewise, some other elements are also like here, like chlorine. Okay. Atomic numbers are same, but they have different atomic weight. So they have different atomic weight. So where could he arrange in 35 or 37? That was the problem. That was the drawback, limitation of Mendeleev's. Okay. And also uh, he could not explain about some elements of at higher atomic weight, like lanthanides and actinides. Okay. So these were some limitations of Mendeleev's. Okay. Then after Mendeleev's, then Mosley's. Okay. Mosley's periodic table. Then Mosley's gave a periodic law, okay, which is also known as Mosley's periodic table, periodic law, which is also known as a modern periodic table. So that what we are using today. Okay. So his periodic table is still they working. Okay. Means people are following this table today. In today we are using this. Okay. So because the first change what he did, before that all the Daubernier, Newland and Mendeleev, all they arranged the atomic elements on the basis of their atomic weight. But this man, Mosley, he arranged the elements on the basis of their atomic number. That's why he's successful. Okay. So Mosley's periodic law, what was it? That he says that okay, physical and chemical properties of elements, ठीक है, are periodic function of the atomic number. We arrange the elements on the atomic number. Okay. So now this modern periodic table, it comprises of modern periodic table. Okay. Is a collection of elements with comparable properties. Okay. What happened here? He put some groups and some periods. Okay. Means some verticals and some horizontal lines. Okay, some vertical lines and some horizontal lines. The vertical are we call as groups. Okay, there is group first, group second, group third, and all like that. Okay, and the horizontal was called as periods. Okay, first period, second period, and third period. Okay, so like that altogether there were 16 vertical columns and 7 horizontal rows. Okay, 16 vertical columns, 16 vertical columns. They are called as groups. Okay, and 7 horizontal rows. They are known as periods. Okay, now his periodic table is able to explain about isotopes, because isotopes have what? Same atomic number, different atomic weight. And atomic numbers are same, means hydrogen, all isotopes have atomic number 1. So all isotopes of hydrogen is grouped in first. Okay, because so no issue with the isotopes. We could explain isotopes. Okay, and transition elements are positioned in the center of the extended periods. Okay, means okay, I will explain how. And every group has their name, has a particular name. So this is the periodic table, modern periodic table. Okay, long form of modern periodic table. This is the group first, group second, third to 12, 13, 14, 15, 16, 17, and 18. And 7 periods. Okay. And this is 18 vertical. Why is there written 760? Oh, it's 18. You know the configuration? Hmm? You know configuration? Okay. Electronic configuration. Okay. Mm-hmm. Features of the long periodic table. On the basis of the electronic configuration, table is separated into 4 blocks: S, P, D, and F. Okay. On the basis of their configuration. Right? It is made up of 7 horizontal known periods. The first period is the shortest and has only 2 elements. The first period there are only 2 elements, hydrogen and helium. The second and third periods are also shortest with 8 elements each. Second and third periods. Okay. Second and third periods, only 8 elements. And after that, fourth and fifth, okay, they are both lengthy with 18 elements there. These are the transition elements. Okay, the fourth and fifth periods are both lengthy with 18 elements each. Okay, the sixth period is the longest and has the most elements, 32 in total. How? Because in between lanthanides and actinides, okay, these elements are there. Seventh period is unfinished and has 26 elements. Okay, still they are searching for the. Still, there may be some elements which are undiscovered. The largest group of third B, which is the largest group, third B, third vertical row, has 32 elements, including lanthanides and actinides. Okay. Each period's first element is an alkali metal, while the last element is inert gas. Okay. Now let me tell you some names. Okay. So group first, these are called as a group first are known as alkali metals. Okay, alkali metals. Group second are called as, these elements are known as alkaline earth metals. Okay, these are known as alkaline earth metals. Okay. And they have no particular name. They are boron family, carbon family, nitrogen family, oxygen family. But group 17 are known as group 17 are known as halogens. Halogens. Okay. And group 18 are known as inert gas. Inert gases, or you can say noble gases. Or you can say noble gases. Are known as group 17 halogen. There's the noble gases, or you can say inert gas. And in between them, they are called the transition elements. Okay. The S block and P block elements are representative elements. D block elements are transition elements, and F block elements are inner transition elements. Okay. See, they are S block. These are called the S blocks. Okay. And they are called the P block. This is the S block. This is the P block. Okay. 1, 2, 3, 4, 5, 6. These 6 are P block. This is D, and this one, they are the F block elements. Okay. SPDF. Okay. How we named them SPDF? How they are grouped? How they are known as S element, S block elements, P block elements, D block, and F block? Their last electron lies on the S. Yes, because their last electron lies on the S orbital. And then in P block, their last element lies on the P orbital. Okay. See, elements having NS1, yes, they are known as alkali metals. Elements having NS2, they are called as alkaline earth metals. Right now I told you. Okay. They are very reactive and can very easily form univalent or bivalent positive ions by losing the valence electron. Okay. See, S block element. We are talking about S block elements. Okay. Like those elements which lie on the group 1 and group 2. We take an example of, give an example of group 1 element. Helium, lithium, hydrogen, lithium, potassium. Group 1. We can take lithium, sodium, potassium. Okay. So what is the configuration of lithium? 1L. 1s2 2s1 ठीक है here 1s2 2s2 2p6 3s1 okay same way 1s2 2s2 2p6 3s2 3p6 19 no? 6 7 8 19 10 16 17 18 okay 1s2 2s2 2p6 3s2 3p6 3p2 or 3p3 oh, it's 19 हेलो और 1 घंटा मीन्स पौने 10 तक पौने 9 तक सॉरी पौने 10 अच्छा ठीक हाँ उसके बाद yeah okay correct 4s1 why we are so confused we are done up to here just 4s1 okay so let's see so what happens here the all ele and the valence electron last electron lies in the s okay what I want to tell you here there's these ns1 elements ns1 they are also they are known as alkyl they are very reactive okay they are very reactive they just lose their last electron and gain a positive charge okay so they just lose their one electron and after losing this electron they become what na plus okay they lose this and become k plus okay so they are very reactive they can easily lose their electron to complete their octet okay why they lose why okay why some elements are reactive some are less reactive some are non-reactive it all depends on what yeah it all depends on the tendency to lose or gain electrons to complete their octet octet means what noble gas configuration okay means they want to complete their last energy shell okay we can I can show this this way this is sodium this is the energy shell okay this is the energy shell the inner one have 2 electrons then the second this is called k second has 8 commodate 8 electron 4 5 6 7 8 and then 1 so every elements what they want to attain the noble gas configuration they want to lose this electron and it will become 2 8 with complete octet okay? That's why it is very reactive but those which have already 8 then what will happen with that those elements which have their last electron already filled last shell sorry last not electron last shell is already filled with 8 electrons will they react no they are known as inert gases that's are inert gases noble gases okay so this group 1 elements they are very reactive and can easily form univalent ions they form univalent ions okay group second that is ns2 with ns2 Okay. With elements with of configuration NH2. For example, magnesium, right? Sodium magnesium. What is the configuration? 1s2, 2s2, 2p6, 3s. हाँ, ठीक है. So it will lose its last two electrons, and what it will become after giving two electrons? It will lose its last two electrons and become what? Mg2 plus. Okay. So all the group second elements which have configuration like NS2, okay, they will lose their last two electrons and become divalent ions, plus two ions. Okay. And bivalent means plus two. Okay. These are the properties of the S block elements. Okay. In S block elements, we have two groups, group first and group second, NS1 and NS2, alkali metals and alkaline earth metals. Okay. These both group come in under the S block elements. Okay. Elements are soft, flexible, and good conductor of electricity and heat. Okay. They are soft, flexible, and good conductor of heat and electricity. Why good conductor? Because they easily form the ions, and ions carry the charge, carry the current. So they are good conductor of electricity. Okay. What happened? My Hindi is not right. You understand Hindi? Yeah. Yeah. Yes. आपके तो मैं 500 रुपए गए थे. हाँ. मेरे हाँ. आपको मिला क्या किसने? मेरे 500 रुपए कल गए. कहाँ पे थे? अरे मेरे मोबाइल से कल 500 रुपए गायब हुए. पता नहीं, मुझे नहीं पता. आपको कैमरा चेक किया गया? नहीं. आपके गए ना पैसे? हाँ हाँ हाँ, वो है टिकट. बता रहा हूँ आपको. हाँ, क्योंकि मुझे ऐसा लगा, क्योंकि मैं श्योर नहीं थी मुझे. क्योंकि आप जब फर्स्ट पार्टीशन में गए थे ना, तब आपने फोन टेबल पे रखा था. फर्स्ट पार्टीशन में मतलब? फर्स्ट पार्टीशन नहीं मालूम आपको? वो रिसेप्शन के बाजू में जो ये है ना विंडो, जब अंदर जाने को रास्ता, वहां पे रखा था ना आपने फोन. ओके. जाने के टाइम किसने लिया? वही मैं बता के देख के बताता हूँ आपको. हाँ, देखोगे कैमरा में? तुम देखोगे? हाँ, देख सकते हो. तुम्हें कैसे पता कि मेरा पैसा गायब हुआ है? मेरे दोस्त ने बताया कि आप कल कैमरे चेक कर रहे थे करके. यस ने. ओके, विल टॉक लेटर ऑन. ठीक है, हम बात करते हैं. क्लास चल रहा है. I'll tell you after that class. Okay? It's not good to discuss. Okay, we're talking about the S block element. I'm feeling hot here. Close from every side. So they are very reactive. Okay? They can easily form the bivalent or monovalent ions. Okay? They are soft, flexible, and good conductor of electricity and heat. They have low melting and boiling point. Okay? Elements have largest atomic and ionic radius, yet the lowest ionization energies in their respective periods. Okay? Means what? Understand? They have elements have a largest atomic and ionic radius. Largest atomic radius. Okay? Means their radius is like this. How you calculate the radius? From center to the outermost shell. Okay? This is the radius. Largest radius, atomic and ionic radius, yet the lowest ionization enthalpy. What is the ionization enthalpy? Enthalpy is the energy to attract one gas to one electron from the ionization energy. Means what? Energy required to remove the outermost electron. Okay, and to become ion. Understand? So what will happen if the atomic radius will increase? Okay, ionization energy will decrease. Yes. Obviously, their attraction will become low. They can easily remove the electron. Yes. There is some attraction. Na? This is positive charge. Nucleus are positively charged. Electrons are negatively charged. So as the atomic radius increases, the distance between in their nucleus and the electrons will increase, and it will gradually decrease. Okay. The loss of outermost electrons occur easily, resulting in the formation of M plus or M2 plus ions in case of alkaline earth metal. Exception case except for the compounds beryllium and other compounds of the elements of this block are predominantly ionic. Understand? Understood this? These metals are and their salts give the flame of distinct color. Sodium salts give the flame of golden yellow color. Means their salt, sodium chloride. Okay? If they burn, it will give yellow color. Elements are huge in size, have a strong reducing character, are very electropositive, and have a low electronegativity, ionization energy, and electron affinity. Understood all the correct of the properties of this block elements? Now we come to the p block elements. Okay. P block elements are those which have their atomic number with their configuration and the last electrons lie in the p shape shell. P shape. Okay. P block elements have atoms with incomplete p orbitals in their outermost shell, or in which the final electrons enters any p orbital. Okay. The general outer electronic configuration of the components are NS2 and NP126. Their general configuration. For example, we can take example of fluorine. Yeah, chlorine, whatever you can take. Okay. Its atomic number is 17. What is the configuration? 1s2, 2s2, 2p6, 3s2, 3p. Five. Okay. The last electron lies in the p. P elements include elements from group 13 to group 18. Elements in group 13 have one electron in their p orbital, whereas elements in group 18 have 6 electrons in their outermost p orbital. See? Like a boron 1, oxygen has the p4, and neon. Neon comes in what? Group 18. All the group 18 elements have their last shell completely filled. That's why they are called inert. Inert means what? Inactive. Yeah. They are not active in participating in reacting. Okay. That's why. Elements do not have any specific color to the flame. With the exception of the fluorine and inert gases, all other elements in the block have varying oxidation state. You know oxidation number, oxidation state? Oxidation number. Oxidation state means what? The charge on the element. Okay, we'll discuss it in later on in detail. Okay. They have high ionization energy. High ionization energy means what? More and the tendency to lose electron will be decreased. Yeah. it will need a very high energy to take out one electron. Okay? It's not an easy job to take electron from the group P elements. Apart than metals, all the elements in this block are insulators. Insulators means what? Then will not flow. Okay? Many elements in this block, including carbon, silicon, beryllium, sulfur, and oxygen, exhibit a catenation and allotropy. Okay? These two terms, catenation and allotropy, you know about that this term? What is catenation? Okay. And allotropy. They are two terms. So these elements show catenation and allotropy. Okay, I will tell you in a short. When you will study, we'll go in detail. Catenation means what? Self-linking property. Self-linking property means just say, for example, carbon linked with carbon, carbon, carbon. This is the catenation. Okay. So some of the elements show this property, catenation. They link with themselves, like silicon, 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 germanium, germanium, and sulfur, sulfur, like this. Sulfur can make a sulfur 8. So it's self-linking property. Means linking by its own element. Okay. Allotropy means what? They like carbon. You know, carbon exists in different physical forms, like graphite. कोई रिस्पॉन्सिबल वहां उसको पूछिए ना, लेक्चर कंटिन्यू चलेगा. हाँ, कंटिन्यू कर देता. आपको पता था? फोन आया. आया. चेक कीजिए फिर मैं आता हूँ. अच्छा सर, अभी लेक्चर्स ये ऑनलाइन ही ना है कोई? ऑनलाइन है. हु इज ऑनलाइन? ऑनलाइन ही चलता है. पर कोई बच्चा नहीं है ऑनलाइन में? मतलब नहीं, यूट्यूब चलता है वो, यूट्यूब पे. ओके, इसलिए ऑनलाइन होता है. तो आप 10 तक हो ना? 9:45 तक. जी 9:45. जी. Okay. See, allotropy means what? Like some carbon. Carbon exists in different physical forms. Okay. So allotropes are those we can say that they have the same chemical properties but different physical properties. Like carbon has two allotropes, graphite and diamond. Understand? Yes. Allotrope means what? Those elements exist in different physical forms, having same chemical properties. Okay. Like the allotropes of carbons are, okay, I can write here, same chemical properties, and different physical properties. Okay. For example, allotropes of carbon. Allotropes of carbon are diamond and graphite. And graphite. Okay. There is a transition from reducing to oxidizing properties as we proceed from left to right. Okay? As because we know that p block elements are the elements of group 13 to 18. P block elements are from group 13 to group 18. They are known as the p block elements. Okay? So what happens that they're reducing properties. They're reducing to oxidizing properties proceed from left to right. As we go from left to right, okay, their reducing property decreases and oxidizing property increases. Okay, you understand? What is reducing property and oxidizing property? Reducing property means what? To reduce other. Okay? And oxidizing property means to oxidize other by getting reduced themselves. Okay. Okay. So we have done S block elements. We have seen the properties of S block elements and P block elements. Okay. And the P block elements, in the P block elements, the halogen groups are what? Group 17 elements. They are very reactive. Okay. And noble gases of group 18 elements, they are very unreactive. They are called inert. Now we'll proceed to the D block element. D block elements. Okay. Where is D block located in the periodic table? Between S block and P block. Okay. They are located between S block and P block. See, these are the S block elements and these are the P block elements. Okay. They are located in between them. Okay. It means their groups are from, they are from 3 to 12. Okay. Their groups are from 3 to 12. Okay. Their properties are intermediate between those of the P block elements. So they are also known as transition elements. Okay. What are their name? They are called as the transition elements. Transition elements. Transition means what? Means they are transiting their property. मतलब they have properties are changing from group S to group P. And they are in between them. Transition element has an atom or at least one of its ions with an incomplete d orbital or the outermost electrons in a d orbital. Means what? The outermost electron lies in the d orbital. Okay. And their general electronic configuration is like n minus 1 d 1 to 10. Okay. N is 1 to 2. Okay. You can take an example of any d block element. You can take any example of a scandium internet. Okay. It becomes like this. So n minus 1 d 1 to 10, n is 1 to 2. This is the general configuration of the d block elements. These elements are found in 3 sets of 10 elements each, ranging from group 2 to group 13. Because of the engagement of Ns and N minus 1 d electrons in the formation of their chemical bonds, they have varying valency and oxidation state. Okay? Means the elements in group D, okay, they have varying valency. Okay, their valencies are means varying, different valencies, and different oxidation states they show. Okay, oxidation state you will see later on in detail. Okay. This is because the energies of these electrons are almost identical. These metals have high melting and boiling points, densities, thermal stabilities, and hardness rating. Okay. These elements have high melting and boiling points, okay, high densities, thermal stability and hardness. They are malleable and ductile. Okay, malleable means what? Malleable is the properties of malleable is the property of metal. Malleable means what? They can be beaten into sheets. Okay, if you will beat them, they will become a thin sheet. Ductile. Ductile means they can be made into wires. Okay, just like metals, they show these properties because they are also transition metals. Because of the existence of mobile of or free electrons, they are good conductor of heat and electricity. Okay, because they also have free electrons, so they show conduct they show the conductivity, means they are good conductor of heat and electricity. They combine to generate colored ions and complexes. Because of the existence of unpaired electrons, these metals and their ions are often paramagnetic in nature. Okay, we'll discuss in detail. You will have a chapter of d block elements, then you will read in detail their characters. Okay, catalysts are frequently made from these metals and their derivatives. Okay, these metals are also used to make catalysts. Catalysts are those uh, substance or those species which are used in any reaction to enhance their speed. Reaction. To enhance their speed. Okay, to speed up the reaction. Okay. These metals are also formed non-stoichiometric and interstitial compounds with small atoms such as the Hc and NO that may easily fit in the unoccupied spots of these metal lattices. For instance, FeO. Okay, we will discuss in detail. Okay. Now, just we'll quickly see metals, non-metals, and metalloids. Okay, because we will have a complete separate chapter for d block elements and f block elements. Okay, in that we will study in detail all these properties. Okay, now this is because this is the just a introduction to this. You understood, na? Yeah. Okay. Now the metals, non-metals, and metalloids. We'll quickly see some differences between metal, non-metal, and metalloids. Okay, metalloids. Metals are okay. What your metals? Metals say solid at room temperature, except mercury, solid. Okay, except at room temperature, except mercury. In general, they are usually solid, liquid, as well as in gas state. Okay, gases. For example, solid example, we can take carbon, liquid, bromine, gases, oxygen, all these. Metalloids are those elements which lie on the borderline between metals and non-metals. Means show the properties that are the characteristic of both metals and non-metals. Okay? They show the characteristic of both metals and non-metals. Okay? They show the characteristic of both metals and non-metals. The metals have generally high melting points and boiling points. They are high melting and boiling, high melting points and boiling points. Okay? They are good conductor of heat and electricity, conductor of heat and electricity. Okay? And what for and the and they metals what they form? They form positive ions. ठीक है? They lose electrons. They lose electrons. ठीक है? And form positive ions. Positive ions are called cations. Okay? They are malleable and ductile. Right now I told you about malleability and ductility. Ductile. Okay? Malleable means what? In sheets. Like you must have seen aluminum sheets used to roll the gold foil. Okay, aluminum foils. Ductility means making wires. Like copper is used to make wires. You can use wires of any element. Okay? And what? They are sonorous. Sonorous means what? They give a special sound. Means they produce sound. Okay? Like pen with iron. Okay? So and with non-metals, they have generally low melting point and boiling point. Okay? They are bad conductor of electricity and heat, but there are some exceptions. Exception is what? Except graphite. Okay? Graphite is a drop of carbon, but it is good bit of electricity. Okay? They gain electron and become negatively charged. Okay? है ना? They use generally gain electron and become negative charged part. Negative charge. Okay? They are non-ductile, non-malleable, non-sonorous. Yeah, one more property. They are brittle. Okay? And metals are non-brittle. Brittle means what? They can be easily broken down. Okay? On putting some hammer, you can easily break it into pieces. Okay? These are some properties of metals and non-metals. Okay. Now I'll see trends in periodic properties of elements. Okay? They are also known as atomic trends. Atomic trends. Okay? Means what? As we see in the periodic table, as we go from top to bottom, okay, there is some trend of increasing or decreasing the properties, or as we go from left to right, okay. So their properties goes on increasing or goes on decreasing, okay. These are called the atomic trends. So first we'll see the atomic radius, atomic size. Okay. So first we will see the atomic size. I hope we are clear up to this. Everything is clear? Okay. Periodic table, group, periods, name with S block, P block, D block. We have not discussed F block. Okay. Okay. Now we'll discuss the atomic trends, means the properties, their physical or chemical properties. Okay. Atomic size. As I told you, what is the atomic size, or you can say radius. Okay. Right now I told you about atomic size. How we calculate the radius or size? Yeah. From the center of the nucleus to the outermost, whatever it will be, the distance between the center of the nucleus and the outermost shell. It is the atomic size or radius. The exact size of an atom's radius can't be found. Okay? We cannot find the exact size of any atom. Okay? Why? Because it's impossible to know where an electron is in an atom, because orbitals don't have sharp edges. Okay, we will discuss about that here. That elements are not in a fixed orbital. Okay? Because an atom is so small, it is impossible to separate it so that its size can be measured. And you know, the atom is very small. It's so small that it is impossible to separate it so that its size can be measured. Got it? Bond lengths, which can be measured with X-ray diffraction, electron diffraction, infrared spectroscopy, and nuclear magnetic resonance spectroscopy, are used to figure out the size of the atoms. Okay? But exact distance, exact size, it's impossible to find out. Since the size of an atom can't be measured in absolute terms, okay, it is described by the terms of like ionic radius, covalent radius, van der Waals radius, and metallic radius. Okay. Depending upon the type of compound. Okay. Ionic means you have London ionic bonding, ionic bond, chemical covalent bond. Okay. Well, yeah. So this is the atomic. Okay. We'll discuss one by one. Atom, covalent radius, ionic radius, and all that. Two atom that are same. See, first you should know what is ionic bond and covalent bond. Ionic bond means what? When the bond formed by the transfer of electrons. Okay. Covalent bond is by when the bond is formed between two same electronegative elements by the sharing of electrons. Okay. The covalent bond is formed between by the sharing of electrons. Ionic bond formed by the transfer of electrons. Okay. So, an atomic size we'll discuss with the covalent radius. Covalent radius. Okay. Obviously, when covalent molecule. Covalent molecule is what? The molecules which are formed by the sharing of electrons. Okay. The covalent radius is it is the half of the distance between the nuclei of two atoms that are same or similar in a covalent molecule. It is also known as the covalent radius. Okay. See, this is a covalent molecule. Okay. These two are the covalent molecule A and A. Why I said A and A? Because covalent molecules, they have almost the same electronegativity. Okay. They are formed by the sharing of electrons. So what is the covalent radius? Covalent radius we can say by, we can write it like RCO, covalent. Okay. What is the radius, covalent radius? It is the, if we'll say the distance between the A and A is half. If we supposed to have if we it is the distance between the nuclei of the two covalent molecule is A, small a. Okay. Then the radius is half of the A. Okay. Understood? This is the covalent radius. Means it is the radius of it is the distance between the nuclei of one atom and this. This is this distance between these two are called the covalent radius. Okay. Next is the ionic radius. Okay. It is the distance from the center of an ion's nucleus to the point where the ion has an effect on the electron's cloud. Okay? Because ionic radius is between between two atoms with different electronegativity. Okay? Because they are formed by the transfer of electrons. So it is the distance. It is distance between these two. Okay, it is called R A plus R. Okay. This is the ionic radius. Okay. Metallic radius, it is tightly packed crystal lattice. It is half of the distance between any two nuclei of the two metal atoms next to each other. So this is all about the radius. Okay. Now we'll see what are the factors affecting the size. This is the most more important thing. Factors okay, affecting the size. Affecting the size or factors affecting the atomic radius. Okay. Okay. As we go in period. Okay. First क्या है? First we'll we'll see in the group. Okay. So what happens here? Size is directly proportional to the number of orbitals. Okay. Size is directly proportional to the number of orbitals. As we go from top to bottom, okay, orbitals, number of orbitals increases. So size will increase. Okay. Size is inversely proportional to the bond order of or multiplicity. Size is directly proportional to the number of inner shell electron. Okay. Same way. Size is proportional to the electronic repulsion. Okay. You can say this one also. Size is directly proportional to the electronic repulsion. Okay, let me explain this. You understand the electronic repulsion? As the size, as the means number of shells increases, okay, their electronic repulsion will increase. The size will increase. Okay. In a period, as we this was about okay. Now in what happened in period, as we move from left to right, sizes reduces. Okay, size will increase. Okay, size in group. Okay, in group. Okay, as we move from top to bottom. Okay, size will increase. Obviously, because the number of shell orbitals increases. Okay, in period. In period. Okay, as we move from left to right, what happens? Size will decrease. And the number of atomic orbitals remains constant, but the number of electrons increases, resulting in an increase in the effective nuclear charge. Okay, so here, see, size is inversely proportional to the effective nuclear charge. Effective nuclear charge. So what happens in the period? Okay, what happens? The number of shells, here, number of atomic orbitals remains same, but the number of electrons increases. ठीक है. Number of shells remains the same as we go from left to right. ठीक है. But electrons goes on increasing right now. And for example, you see uh, you'll see from carbon to chlorine. ठीक है. Carbon, see, 1s2, 2s2, 2p6, 3s, 2p. नहीं, ठीक है. 1s2, 2s2, 2p. Then after as proceeding from left to right, then they become 2p3, 2p4, 2p5, 2p, like this. Okay. So what happens here? The number of shell is constant, fixed, but what increases here? Electrons. So the effective nuclear charge goes on increasing. So the size is decreasing. Okay. The order of atomic radius for various groups is given as first A, then second A, then third A, okay, then fourth A, fifth A, okay, sixth, seventh, okay, and so on. So what is this? This is the decrease in the size. Okay. Likewise, lithium, then beryllium, boron, carbon, nitrogen, oxygen, fluorine. Sodium is bigger than magnesium, then aluminum, then silicon, then phosphorus, then sulfur, then chlorine. Okay. Okay, we have discussed about the group. About the group, okay. As we go in the group, the size increases. Yes. Okay. Let's say in group, what happens? Lithium is smaller than sodium, then calcium, potassium, then rubidium, then cesium. Okay. The biggest one is the cesium. As we go from top to bottom, size increases. As we go from left to right, size decreases. Okay. Clear? In periods it decreases, in group it increases. Okay, size of the cation and anion we'll discuss later on. Now the ionization enthalpy. Ionization, second property, second term is ionization enthalpy, or you can say ionization energy. Okay. Known as ionization energy, or you can say ionization potential, whatever. It is defined as the amount of energy necessary to remove the most loosely attached electron, or it is amount of energy required to lose the last electron, okay, from a gaseous isolated atom, resulting in the production of positive ions. Okay, means suppose this is an atom M. Yes. Okay, what is the ionization enthalpy? To lose is it's one electron. Okay, one electron is removed. It becomes what? M plus. Okay. So this is the first ionization enthalpy. Means ionization enthalpy is to remove the energy required to remove the last electron, the most loosely attached electron. Okay. So suppose M is an atom, we lose one electron, it becomes M plus. Okay. This is known as the first ionization enthalpy. Okay. Now after that M plus, if the energy required, now it becomes M plus, already one electron is removed. Yeah. After that, the next energy is required to remove the another electron. Okay, next electron. Again, when the electron is removed, so what will become? M plus plus, yeah, M2 plus. And this is known as the ionization energy, second ionization energy. Okay? And after, next is what? M2 plus. Okay? Now the energy is required to remove third electron. Okay? Yeah, you can say the energy required to remove an electron from M2 plus. So what it will become now? M3. Okay? And this is called the third ionization energy. Okay? Now, here what happened? This is the first ionization enthalpy, second ionization enthalpy, and third ionization enthalpy. Okay? And we will arrange in the increase in the like, so which is the most, okay, obviously of the removing of this the electron from M plus 2 is more. We will require more energy to remove an electron from already cation, M plus 2, right? Then then after that M2 plus, and M plus 1 means the least energy is required to remove an electron from that atom. Okay? The value increases as removal of the electron becomes more and more difficult. Okay? Yes. Means what? The ionization enthalpy, the value of ionization enthalpy increases as, okay, as what? As the removal of electrons become more difficult. Okay? And ionization energy is always positive because energy is always required to remove the electron from an atom. Yes. Okay? Always there is some requirement of energy to remove the electron. So it is always in positive state. Okay? Its units are, what is the unit of ionization enthalpy? Unit. Okay? Electron volt per atom. Okay? Or you can say kilocalorie per mole. Or it may be kilojoule per mole. Okay? These are the units. We have to calculate. We have to put this unit. Ionization energy is directly proportional to the nuclear charge. Ionization energy is inversely proportional to the atomic size. Okay. So ionization energy is what? It is the energy which is required to remove the loose electron. Okay. First ionization energy it is lesser because it is for the removal of the first electron. Now the second ionization energy is what? The removal of electron from M plus. And third is the removal of the energy required to remove the electron from M2 plus. Okay. Ionization energy, okay, is directly proportional to the nuclear charge. Understand? Right now we have done that the M2 plus is more than M plus, okay, and M plus is more than M, simple M, like that. So as the nuclear charge increases, ionization energy increases. Okay. So ionization energy is directly proportional to the nuclear charge. Okay. Right now we have seen this. Okay. And ionization energy is inversely proportional to the size, atomic size. As we go from top to bottom, okay, atomic size will increase. Okay, and the ionization energy will decrease because it will become easier to remove the outermost electron. Okay, because the attraction between the nucleus and the electron becomes lesser. So the less energy will be required to remove the electron. This indicates that the higher the magnitude of the ionization energy, the closer an orbital is to the nucleus. It means what? Ionization energy is higher, but it indicates the atom is closer to the nucleus. The electron orbital is that or light outermost electron in orbital is closer to the nucleus. Yes. Due to the larger force of attraction between the electrons and the nucleus. Okay? The amplitude of the ionization energy increases in the following orders, like S, P, D, and S. So I think it is wrong given. It is wrong given. It is all in your book. Mhm. It should be uh, lesser for S. Yes, yes. You know, I just wrote down this. It should be lesser for S than P because the removal of electron is easier in S. Yes. Okay. We have seen the ionization energy in group, in period, in a period, moving from left to right. Yes. In a period, increases the ionization energy. Okay. And the size decreases. Okay, now we have not seen about a ionization energy in group and period. In a period. In group, we have seen in a group. Okay, what happens with ionization energy? As we go from top to bottom, ionization enthalpy will decrease. Okay, and in a period, as we go from left to right, okay, ionization enthalpy will increase. Value of an initial ionization enthalpy in a group is greater than the group third A. Because okay, Okay, it means in ionization energy, okay, is directly proportional to the stable electronic configuration. Okay, means every element want to complete their to attain the stable electronic configuration. Okay, so if they have already stable configuration, the taking out of the electron is difficult. So ionization energy will increase. Okay, so we can say that ionization energy is directly proportional to the stable electronic configuration. Electronic configuration. Okay, so you'll see if we will see group second A and group third A. If we will see group second A, okay, and group third A. If we will compare with this, okay, which will have a higher electron ionization energy?
Group second A.
Because what is the configuration of group second A? Electronic configuration of group second A is NS2. Okay? And group third A means it becomes P block element. So NS2 and P1. Done. So this is the more stable configuration, right? And this is the is the less stable configuration. Means NP1 one orbital is incomplete.
Yes.
Incomplete. Okay, incomplete p orbital. So the ionization energy of group third A will be lesser than group second A. Okay, so ionization energy is directly proportional to the stable electronic configuration. Clear?
Yes.
Okay. End kar di. Okay, next we will study about electron affinity. I hope understood with